Hello, good afternoon, good morning to everyone. You are welcome to our second class on biostatistics, and we'll be talking about probability. Now, the last class we talked about what biostatistics is, what biostatisticians do. Then we went ahead to talk about what is data, talked about population, sample, reasons why we need to sample, the things the factors that we consider while sampling. Then also talked about types of what sampling. There are two types. We said probability sampling method, probability sampling method, and non-probability sampling method. I will talk about the different types of non-probability and that of what probability sampling. From there, we enter descriptive statistics, which we talked about measure of central tendency, the mean median mode, measure of dispersion, the variance, standard deviation, range, and lots of that. They talked about our descriptive statistics, which is also the charts. I will talk about the bar chart, the pie chart, the histogram, the line graph. Now I'll be moving forward and I'll be talking about probability. What is probability, if I may ask? Probability is a branch of mathematics that deals with the occurrence of a random event. That is, it is the likelihood of an event to occur. We can also say that it is what? A game of chance. That is, either it might happen or it might not happen. So that is why it is called what? Probability. There are some key basic definitions or terms used in probability, like the sample space, the event, the outcome, the experiment trial. Now I'll talk about sample space. Sample space is a set of elements that represent all possible outcomes of an experiment. Usually it is denoted by the letter S. When you see S, means we're talking about sample space. Then event. What's an event? Event is a set of outcomes of an experiment. That is, event is a what? A subset of the sample space. For example, we talk about a coin. A coin has how many faces? Two faces. So our sample space is what? Two. Either a head or what? A tail. So we're talking about an event. An event that can occur in a coin is either what? A head or what? A tail. You can see a head is inside the sample space, head or tail. A tail is inside what? The sample space, head or tail. And let's go to outcome. Outcome is referred to all possible distinct results of a trial. Then what is an experiment? Experiment is the process through which outcomes are generated. That is, for example, those of us that like playing Ludo, throwing of a die, tossing of a coin, all these are what? Experiments. It can also be called what? Trial. Now, there are basic things we need to know about probability, which are what? The characteristics of what? A probability. Now, characteristics of probability, you are talking about one. The first characteristic of probability is that probability of an event is always between what? 0 and 1. If you are solving probability and you are now getting minus 0 point something or you are getting 1 point something, then you are wrong. I don't need to look at it. Any mathematician does not need to look at it. You don't mark you 0. Probability is always between what? 0 and 1. The second characteristic is that the probability of a sure event is what? 1. Probability of a sure event. What do you mean that? What is today? Today is what? Tuesday. What is the probability that tomorrow is Wednesday? Definitely tomorrow is Wednesday. So the probability is what? 1. What is the probability that it will become dark after the sun sets. After sunset, what happens? The sun goes down, darkness comes up. So it is what? 1. After day, night. So any event that I know is setting, it is what? 1. Then the third is what? Probability of an impossible event. The probability of an impossible event is what? Equals to 0. Probability that I know that is not possible. What if, like, for example, let me ask, what is the probability of finding a 10-year-old in the university? Is it possible? You pass through primary school, secondary school, then university, you are getting a 10-year-old. No, it's not possible. The least you can get now is 14, 15, not a 10-year-old. So that is what? 0. Then fourth, the sum of all probability is equal to what? 1. The probability of A, probability of B, probability of C, probability of D till any must be always be equal to what? 1. The last is what? If the probability of an event happening is A, then probability that the event will not happen is what? 1 minus probability of what? A. That is 1 minus probability that the probability that an event will not happen is equal to 1 minus the probability that the event will what? Happen. So that is it. And also, generally, probability of an event happening is given as what? Number of required outcome over number of what? Possible outcome, which is equal to what? N into bracket E, close bracket, all over what? NS. NE over what? NS. That is event all over sample space. Now, for reference purposes, the formula for finding sample space of a coin. How many faces does a coin have? 2. So number of sample space is what? 2 raised to power what? N. Where N is what? The number of trials. Then for dice, how many faces of dice are? 6. So probability of having what? Sample space for a dice is 6 raised to power what? N. 6 raised to power what? N. 6 raised to power what? N. Okay. We move forward. From the material here, you see examples on what? Probability. Let's go to different types of probability. We have what? The theoretical probability. We have under the theoretical probability, we have what? The mutually exclusive event and non-mutually exclusive event. Also, we have okay, let me explain this first. Let's go to the okay. Now, theoretical probability. This is probability that is calculated without the experiment being performed. Probability that is calculated without the experiment being what? Performed. For example, we have what? Find the probability that a number selected at random from 41 to 49, from 49 to 41. That is, what is our sample space there? Our sample space is what? N minus N. That is, how do you get our sample space? You are saying from what? 41 to 46. You can do your normal counting, but you can say 46 minus 41 plus what? 1, which will give us what? 15 plus 1, which is 16. Our sample space is what? 16. Now, the first question is, what is the probability of having what? A multiple of 9. What are the multiples of 9 we can find in 41 to 56? Is what? 45 and 54. And how many is that? 2. And what's our sample space? 16. So is equal to what? 2/16. Answer is equal to 1/8, which is the same thing as what? 0.245. Okay. Let's move forward. But a coin and a die is tossed up together. What's the probability of a head and a 6? Solution of. What is we are tossing a coin and you are rolling a dice. So what is the probability of adding a head and a 6 showing up? What the probability of having a head and a 6 showing up? Now, what do we have here? What is the probability of what the sample space for a die is what? 6. And probability of a head showing of a 6 showing up is what? 1/6. And what the sample space for a coin is 2. The probability of a head is what? 1/2. Therefore, probability of a head or a 6 is equal to 1/6 times 1/2, which is equal to 1/12. Then from there, let's go to empirical probability. Let's go to empirical probability. Empirical probability is calculated using the result of what? Experiments or trials in school. That is, empirical probability is equal to the sum of F all over that is what we are saying here is that the probability of empirical probability is what? Summation of E all over summation of F. Summation of E over summation of F. You see that in the note. Let's move on. Let's go to addition rule. This is divided into mutually exclusive event and non-mutually exclusive events. We are saying that mutually exclusive events, it occurs, the occurrence of one does not affect the other. That if you have two events, the occurrence of this of A happening does not affect the occurrence of B happening. Such events are called what? Mutually exclusive events. Then from there, we have solved examples here. Then we move to non-mutually exclusive events. Non-mutually exclusive events. Two events A and B are said to be non-mutually exclusive if the occurrence affects the other. If the occurrence of one affects the other. If the occurrence of one affects the other. That is, they have something in common. As when we have probability of A and B, when there is an intersection between A and B, then it is what? A non-mutually exclusive event. The occurrence of this affects the other. So it is given as probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So that is the formula. From there, okay, let's solve an example. An event A is obtained. An event A is obtaining a prime number and B is obtaining an odd number in a single throw of a die. Find the probability of A or B. What is our sample space for coin? Is what? 1 to 6. 1, 2, 3, 4, 5, 6. Then, what the probability of A occurring, which is a prime number? What are prime numbers? Prime numbers are numbers that, what's the prime number? A prime number is a number that can only be divided by what? Itself and 1. It has 2 factors. So in numbers 1 to 6, what are the prime numbers there? 2, 3, and what? 5. 2, 3, and 5. Then the second event B is what? An odd number. What are the odd numbers? 1 to 6. 1, 3, and 5. So therefore, probability of what? A intersection B. What will it give us? It will give us probability of 1 minus 6. No, 1 all over 6. No, let's split this. We are saying that probability of A or B is equal to probability of A plus probability of B minus probability of what? A intersection B. Now, how many elements do you have in A? 3. How many elements do you have in B? 3. So it will now give us 1 all over 6, 3 all over 6 plus 3 over 6 minus the intersection. The intersection is what? 3 and 5, which will give us what? 2 all over 6. So what's ICM? 6 divided by 6 1 times. This will give us 3 plus 3 minus 6. So our answer is what? Our answer is 4 over 6, which can be further divided into 3 all over 6. Now that is addition. Let's go to multiplication rule. The multiplication rule, we have independent and independent assets. And we have that the dependent and the independent events, the word S is and is used in what? Multiplication rule. Why the word or is used in what? Addition rule. Addition rule. For example, let's solve one example here. A pair of die with each face numbered 1 to 6 are thrown up. What probability do find probability of securing a 2 on? Okay, we are a pair of die with face 1 to 6 are thrown once. Find the probability of scoring a 2 or a what? Solution. So what probability of picking a 2? When you throw die, what probability of picking a 2 is what? How many times this 2 occur? 1 over 6. Then what's the probability of picking a 5 is what? 1 over 6. Therefore, A intersection B is equal to probability of A plus probability of B minus probability of AB. Okay, by the time we solve it, let's move to the next one. Please do this as assignment for me. The other probability question. So let's move to probability distribution. What are probability distribution? Probability distribution is the listing of all possible events and corresponding problems of a discrete random variable. Okay. The distance variable in a numerical event whose number is low. We have different types of probability distribution. We have the what? The normal probability distribution. We have the Poisson. We have the binomial. We have the binomial. Now let's go to binomial distribution. Binomial distribution. Most of these, we are supposed to have done it in sampling data, our 300 level first semester. 300 level first semester. Some of these courses are also there. Okay, let's move on. We are talking about binomial distribution. Binomial distribution is given n trials. P is the probability of success and Q is the probability of failure. Where X is a random variable, the binomial distribution formula is given as Px equals to n combination X, P raised to power X, Q raised to power what? N minus X. I said it is what? N X. That is n combination X times P raised to power X times Q raised to power what? N minus X. Okay, let's look at an example there. We have a new car salesperson knows from past experience that she can make sales of about 20% of her customers. Find probability in 5 randomly selected attempts that make a scale of exactly 3 customers, at most 1 customer, exactly 1. Then determine the probability distribution. Determine probability distribution of the number of what? Scales. Now, okay. By the time you solve, you come to get what? Our variance will give us 0.76. Find the standard deviation, which will give us what? Something. You have 0.85. Now let's go to Poisson. We'll because of time, I'll just give you the formula. I've given you formula for binomial. Let me give formula for what? Poisson. Now we make use of Poisson distribution when our n is large. That is less than or greater than what? 30. Now, Poisson distribution is saying that probability of X occurring is equal to what? X occurring, and so it is probability of X occurring is equal to what? Exponential minus X times lambda raised to power X over X factorial. What do we mean by X factorial? Most some of us will be looking at what do we understand? We don't understand what factorial means. For example, I have 3 factorial. 3 factorial, that's multiplication downwards. That is 3 times 2 times 1. 5 factorial will be what? 5 times 4 times 3 times 2 times 1. So that is what? Factorial. Okay. Let's go to our, what is clinical trials? Clinical trials. Clinical trials are research studies that evaluate the safety and effectiveness of new treatments. The safety and effectiveness of what? New treatments, devices, or procedures in what? Humans. They are a vital part of development in new treatments for various diseases. Hence are some things we need to know about clinical trial. One, what is the purpose of clinical trial? Clinical trials assesses the effects of new interventions on health outcomes, such as reducing the risk of mortality, improving quality of life, and relieving symptoms. Now, for example, you see our healthcare facilitators and some nurses, they go around, tell people about this immunization, the effect of it, polio. Anytime diseases, there's outbreak of disease, they tell the government, so they make awareness of it and start to find solutions to curbing such outbreak. Like we saw what happened during the COVID-19. Also, there are phases of what? Clinical trials. Clinical trials can be conducted in 4 phases, each with a specified goal. Each phase has its own what? Goal of achievement. Now, phase 1. The first thing we need to do in phase 1 is what? Test a new drug in a small group of people to identify side effects, determine a safe what? Dosage range. Now, when a new drug is being brought out, now what we do is before it can be released to the public, they need to test the drug. For example, maybe they get about 10 patients and then they give them the drug. If more than 2 or 3 react to the drug, what do you think would be the best thing to do? You withdraw the drug and go and what? Modify it. But if you have about 1 person, maybe then the drug is safe for what? Use. Then you cannot advise that they can release it to the public. The second phase is then test a treatment that was safe in phase 1 on a larger group of people to monitor for what? Adverse effects. Now, after doing the first one, the second one will now take you to the larger group people and see monitor effects. You know, everybody has his own body system. So now to see how many reactions. If reactions is high, then we can now what? Retrieve the drug from what? The larger populace. The third is what? Test a treatment on a larger group in different regions and countries, often before it is what? Approved. You know, like during that COVID-19, it affected the whites very well in Europe, in America, and so, but you can see that the effect was not much on Africa. So they need to test for various type of drugs that will both fit for both black and white to the larger populace. Then the fourth phase is it takes place after approval to further test the treatment in a wider population over a longer period of time. under a long period of what? Time. Okay, let's move on. We talked about what? Process. We talked about process of what? Clinical trials. Process of clinical trial. Now, the process of clinical trial. Clinical trials are carefully designed and reviewed and require approval from an institutional review board. Participants must also give informed consent. So these are the process. Then we talk about what? Outcomes. Clinical trial outcomes can be what? Reported as positive, negative, or non-inferior. They are often presented at conferences or published in scientific what? Journals. Then we also consider what? The cost. The cost of a clinical trial varies depending on the phase. Depending on the phase, the type of trial, and diseases being what? Studied. I believe with this, we are good to go for the exam. We have talked about probability, talked about clinical trials, talked about biostats, talked about our charts, our graph. Because of time, I will employ us to go and read up some, a very few aspects of it, as in the test, the chi-square, the test hypothesis. The material is there, so you can go through it. And please, as you are attending the class, indicate by writing your name, your level, your information, reg number, username, then the center that which you are. Thank you, and God bless you.